Morning, learners. Welcome to our second lesson on physical science. So today's topic will be on kinetic and potential energy. And before we dive into that, let's quickly have a recap. And before the recap, quickly write your names in the chat so that I can take attendance. Even if Microsoft Teams take its own attendance, I still need Zeta to verify. So like I said, today's topic will be on kinetic and potential energy. And the next, can you guys see the slides?
Yes, we can see the slide.
Okay, moving on. The next slide is on the content that will be covered in this lesson. The very first thing we are going to do is we are going to recap on the previous lesson, which was on energy conservation. And then we will do the history and definitions of both kinetic and potential energy. I will elaborate and give the differences between potential and kinetic energy. We'll dive into their formulas. I'll give some examples, questions, and conclusions, homework, and ending. That will be it. And the next, moving on to the next slide. These are our lesson objectives, what I'm expecting you guys to gain from this lesson at the end of this lesson. So the first thing, we are going to drive the equations for motions we are going to drive the formula for kinetic energy from the equations for motion. Then we are going to recall that formula and apply it in practical examples and also in some examples that I attached in the notes. We'll apply the relationship between force and potential energy in an uniform field to solve problems. Then we'll derive from the equations of work done the formula for potential energy. Then we'll recall and use the formula for potential energy as well. So moving on, we will be, I want to put the slides in slideshow or something so that you guys can see clearly. Okay, that's better. Okay, moving on to that's the first slide, now the second one, the third, and then moving on to the next thing that we are going to do as per our content for this lesson. The next thing we were going to recap on what we previously discussed, which was energy conservation. Can someone tell me what is the law conservation of energy states? Does anyone want to volunteer and give us an explanation? Or just to read on the PowerPoint what it says. Can we have a volunteer, please? Or should I just continue?
All right, let me answer.
Thank you, Sarah.
The law of conservation of energy states that energy can neither be created nor be destroyed.
Thank you so much. So, as we previously discussed in our previous lesson, the law of conservation of energy states that energy can either be created nor be destroyed, but it can be transformed from one form of energy to another. Let me say, for example, if a person is consuming food to get chemical energy, and then when they start working, that is now kinetic energy. And if they, let me say, for instance, jump off a cliff on a high mountain cliff, that is now potential energy. Yes, so let's move on. There are people that wants to join. Let me quickly just accept them. Moving on, we have a clip of a video on the differences between potential and kinetic energy. So let's just quickly have a look at it. Let me play the video. Can you guys hear? Can you hear the video? Sarah? Okay, let me just play. So the video is basically demonstrating to us what kinetic energy is, which is the energy that's involved in motion. Yes. So let's just quickly skip to potential energy. It shows the video shows that when the ball is in the air, that ball have zero kinetic energy, but because it's constant, there's no motions, and but the potential energy it's at its peak because of the race and the displacement. Yes, that's true. The higher, the more height the ball, like the more you raise the ball up, the more the kinetic energy and the less, the more the potential energy and the less the kinetic energy, since the ball is stable in the air. So let's quickly just move on from that. The next slide basically is just a recap of what the video demonstrated. It's a definition of kinetic energy, which is defined as the energy that is produced by an object due to its motion. When an object is set to accelerations, there's a definite need to apply certain forces. And then potential energy is a stored energy that depends upon the relative position of various parts of the system. Okay, moving on to the formula of kinetic energy. The formula of kinetic energy is equal to A is equal to 1 over 2 mv squared. So this is basically the mass and then the velocity, since kinetic energy has to do with motion. So there should be a body, and that body is in motion. So that gives now the velocity. Moving on to the derivative of the formula for kinetic energy from work done. So changes in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy that will give you work done. And then you differentiate TW is equal to force times distance, since work done is equal to force times distance. And then the formula for force is the mass times the acceleration. So you differentiate that, then you get TW is equal to mvdv, and then you integrate to get the formula for kinetic energy. So where m in the equation is the mass of the body, which is normally given in kilograms, and v is for velocity, which is given in meter per second squared. Okay, I'll just quickly admitting someone. Yes. Okay, moving on to the next slide. This is just a clip to demonstrate the mass of the object and the velocity of the object at which the object is moving. As you can see, I'm quickly just admitting people. Okay, let's move on. As you can see, the height and the speeds, they are changing, and these signs right here. Okay, let me just put on a eraser so that you guys can see. The bars here, this shows the amount of kinetic energy at that particular time when the car is traveling. Let's just quickly replay that slide. Okay. You see the car is there, the kinetic energy is low. When it's moving up here, the kinetic energy is still low because on the potential energy was at its peak. Okay, moving on to the next slide. Okay, the next slide is about problem-solving skills, which involves an example of on how to apply the formula for kinetic energy. So it says solve for kinetic energy. A jogger with a mass of 60 kilograms is moving forward at a speed of 3.0 meters per second. What is the jogger's kinetic energy? And for you to improve and master your problem-solving skills, you have to set up, like you identify what the question is asking, which is normally called identify the unknown. So in this case, the unknown is the kinetic energy, and you list the amount, the knowns, things such information that you are provided with. And in this case, you are provided with the mass of the jogger, which is 60 kilograms, and then the velocity, which is 3.0 meters per second. So, and you have to be really considerate of the units that you are given. So in most cases, you might need to convert to SI units. Yeah, and then you set up a problem. So kinetic energy is equal to, as we previously discussed, its formula, 1 over 2 mv squared, and then you put in the formula and then you get the kinetic energy in joules. So moving on, it's an activity which is about solving the problem using the equations for kinetic energy. So it says a car is moving at a velocity of 10 meters per second and is having a mass of 250 kilograms. What is its kinetic energy? So let me just get a pen. Okay. So you identify what the question is asking for. The question is asking you to find the kinetic energy. How do you find kinetic energy? You find kinetic energy by using the equation for kinetic energy. And then in the equation for kinetic energy, it says 1 over 2 mv squared. So you are given the mass, which is equal to 250. So I'm sorry, I could have chosen to work on a whiteboard, really, but my option is not allowing, this PC is not allowing that option. Okay, and then you insert your variables into the equation. So 1 over 2m, which is at 250, the velocity, which is 10 meters per second, and you square it, and then you get the formula, you get the answer for kinetic energy. Let me just erase. Okay, yes. Okay, the mass of the body, just like I explained. Okay, moving on to the next slide. It's another activity. Can someone just read the question for us, please? Someone to volunteer and just read what the question says.
All right. Question 3.
Thank you, Sarah. Yes.
Determine the kinetic energy of 625 kg roller coaster car that is moving with a speed of 18.3 meters per second.
Yes, thank you so much, Sarah. So the question is asking for you to determine the kinetic energy of a car, of a roller coaster car that's with that mass, 625 kilograms, and it's moving at a speed of 18.3. So using the same problem-solving skills by identifying the unknown, identify what you are, all the information that you are given, and you insert that back into the equation. Yes, the given mass, the velocity, and then you use the formula for kinetic energy, and then you get your kinetic energy in joules. In some cases, you'll be asked to get it in kilojoules, so you should know at this point the SI units conversions. Moving on to potential energy, we say potential energy is the stored energy an object has because of its position or state. Potential energy is mostly at its peak in a higher rate environment. Okay, moving on for the derivative of the formula for potential energy. Change in potential energy is equal to the negative work done. The negative in the in the equations, it comes from the downward gravitation. Because if the object is up in the air and you are pointing it downwards, that's negative because it's going down. That's why we have a negative in that equation. Okay, let me just, for instance, draw here. We have, oh gosh, okay, this drawing is not the best. But let me say, for instance, this is the height. I'm gonna name it h. And then we have a ball dropping. This ball is being pulled by gravity and the ball have a mass. So the change in energy there is equal to the mass times the gravity times the, let me just admit someone quickly. Okay, times the change in height. Let me say the initial and then the final. So you take the final displacement, Fy, minus the initial displacement, and then you get your formula for potential energy. Okay, do you guys have any questions so far? Or should we proceed? Okay, I will take that as a yes. I'm moving on. So the formula for potential energy is mass times the gravity times the height, which is the displacement. So as you can see here, the mass is given in kilograms, and then the G for gravity is given in newtons per kilograms, and the height in meters. So you have to be very careful with the unit convention. So moving on, it's an activity on potential energy. It says a ball of mass 2 kilograms is kept on a hill of a height 3 kilograms. What is the potential energy possessed by it? So you know what you are asked. You're asked to find potential energy. So you go to the formula for potential energy. What does the formula for potential energy entails? The formula for potential energy entails the mass, the gravity, and the height. You know that the ball have a mass of 2 kilograms and the gravity is usually 9.81 kilograms, newtons per second. And then the height, the ball is on a hill of 3 kilometers. But the formula that we use for the variables that we need for height, we need the height to be in meters. So you convert your 3 kilograms to meters. So here we have it. It's the 2 kilograms multiplied by 9.81 and the 3 kilometer converted to meter. And then you get your potential energy in joules. Okay, moving on. Moving on is just another example, but this time the car is driving uphill, meaning that it's inclined. But you are given the mass, the gravity, and the height, so you just plug it back into the formula and you get your potential energy in joules. So that is it for today's lesson on physics. So we'll just quickly do a recap of what we have discussed so far. So far, we have discussed what kinetic energy is, what potential energy is, what are their equations, formulas, and how to apply them. So as you can see, this I think this golf person or something, they are hitting a ball. So at this point, the ball have high kinetic energy and low gravity potential energy because it's not in motion. It's not, I mean, it's not high up in the sky, so the potential energy is low. And here, the potential energy is at its peak because the ball is up at its raised high displacement level. And then the kinetic energy is low because there's no motion, the ball is constant. Same applies here, the kinetic energy is high and the potential energy is low because the displacement, the height is not high enough. Okay, moving on, this is your homework. If you guys can just copy that down and I will be expecting it on our next lesson. And that's it for today. If you guys have any questions, inquiries, or anything that you'd like to add or clarify on, you can ask that now. And I also inserted some reference for you guys to, if you want to further read on this potential and kinetic energy, you can visit these websites and you should be able to download these notes as well. Let me go back to your homework so that you guys can copy it. And we'll check in the chats for you guys' attendance, and thank you for being here if you guys don't have any questions. So that's it for today. So we'll move on to the next lesson, which is mathematics. Let me just share the notes. Just preparing the notes. Good morning once again, learners, and welcome to your mathematics lesson for today. So today's lesson will be on arithmetic sequences, mostly focusing on, so the topic will be on sequences and series, but we are mostly going to focus on arithmetic sequence. So let's move on to the lesson content of what we are going to do today. And I will need also you guys to drop your names in the chat, and I will take the attendance from there. So the first thing we're going to do is recap on our previous lesson, which was solving equations with one unknown. Then we'll go through the objective of these lessons, we'll go through some definitions, and then we'll do the recognition and identifying of the arithmetic series to determine the common difference, finding the nth terms and using the formulas for the nth terms, and for the sum of the first nth term to solve problems involving arithmetics, and we'll conclude homeworks and ending. Okay, these are the lesson objective, what I'm expecting you guys to know at the end of this lesson. I'm expecting you guys to be able to use the n is equal to a plus b formula, where n is a positive integer, and then I will expect you guys to be able to identify an arithmetic sequence among others and use a formula for the nth term and the sum. So a recap on our previous lesson. Our previous lesson was on solving equations with one unknown. Like example 1, it says negative x is equal to 12. So I need you to solve for x. So in order, like we discussed on our previous lessons, we see that you just divide the negative over on both sides. Then you will have your x is equal to negative 12. That's it. So can someone please volunteer to do the next example? Please, can we just have someone to, you can just state it.
Okay, the second answer will be, you first divide both sides by -1, and then you'll get g equals to 5.
Yes, thank you so much, Sarah. Thank you. Okay, let's move on to the next one. The next one is similar to the very first one. So you just divide on both sides, then x will be equal to negative 33. So that was our previous lesson. So let's move on to the next, to today's lesson. So today's lesson, I said it's on series and sequences. So let's start by defining what series and sequences are. So a sequence is a list of numbers that form a pattern. Each number in a sequence is a term. So a sequence is a list of numbers, but those numbers should have a constant pattern. And each number in the sequence is there, we refer them to as terms. Moving on. Okay, let me say this. There is a 0.2, 0.4, 0.6, 0.8. So 0.2 is the first term, 0.4 is the second term, and 0.6 is a following term. The sequence just goes on like that. So for you to find the common difference, you have to subtract the first term, the second term from the first term. The first term the last term to the previous term, next term from previous term, like what they did. They subtracted 0.4 minus 0.2, that will give you 0.2, and then you do the same, 0.6 minus 0.4, that will give you 0.2. So that is a sequence now because it have a pattern, and it's arithmetic because the numbers are constantly increasing at the same rate. Moving on is an example on how to identify arithmetic sequences. How do you know that that sequence is an arithmetic sequence? For you to do that, it says determine whether the sequence appears to be arithmetic sequence. If so, find the common difference in the next three terms. So for you to identify that the sequence is arithmetic, you have to first find the difference between successive terms. So we can start with 8 minus 10, that will give you negative 2, 5 minus 8, that will give you negative 3, 1 minus 5, that will give you negative 4, which means that there is no constant pattern there. So this series is definitely not an arithmetic sequence. Okay, the difference between the successive term is not the same because 10 minus 8 is negative 2, then negative 3, negative 4. So the sequence is not constant. So this sequence is not an arithmetic sequence since the difference between successive terms is not the same. Is that clear? Yes, Sarah, you have a question? Please.
Yes, ma'am. I think I missed a point. What's an arithmetic sequence again?
Okay, let me just thank you for the question. Let me just go back to the first slide where we have a definition. Okay, here. An arithmetic sequence is a sequence. First, a sequence itself is a list of numbers that often forms a pattern, and each number in a sequence is a term. But now there are different types of sequences, arithmetic and geometric. So arithmetic, for it to be an arithmetic sequence, then now the differences should be the difference between the successive term. It should be constant. And as you can see in this example, the difference between successive terms is not the same at all. So hence, this sequence is not an arithmetic sequence. For it to be an arithmetic sequence, the difference between the successive terms have to be the same. Did I answer your question, Sarah?
Yes, ma'am.
All right, thank you. Let's move on. Moving on to example number 2, it says determine whether the series appears to be an arithmetic sequence. If so, find the common difference in the next three terms. So like we discussed, the first step is to find the difference between the successive term. You can start with 1 minus 4, and then negative 2 minus 1, negative 5 minus negative 2, and then you check if the differences between the term is the same, then you can consider that series to be an arithmetic sequence. Okay, you start with your 1 minus 4, negative 3. So you add negative, okay, so the common difference is negative 3, which is the same, meaning that this sequence is an arithmetic sequence. And the common difference is negative 3. The common difference is the difference between the successive term that is constant. So that's what we call a common difference. Then you're moving on, the same example is continuing. If it says, if so, find the next three terms. How do you find the next three terms of it? Or the next 3, 4, 5, 6? That's why we call it the next nth term of an arithmetic series. So to find the difference between those, to find the next three terms, you know what your common difference is. So you use the common difference to find the next three terms. Okay. So the sequence appears to be an arithmetic sequences with a common difference of 3. You saw the next three terms, so you keep adding Now the -3, -5 plus -3, that will give you -8. -8 plus -3, that will give you -11. You know that the series is an arithmetic sequences, and you know that your common difference is -3. So you add that -3 to the last number so that you can get the next 3, 4, 6 terms. Okay, moving on. This is just a definition. The n is usually based on the position of the term. Let me say if this is 1, 2, 2 is the second term, depending on based on its position. Okay. And moving on, the first term, the second term, the third term, the terms are called the nth term based on their position. So the formula for a1 plus n minus 1d, this means the first term plus n, the position of whatever number you are being asked is minus 1, then brackets, and then d, which is our common difference that we just discussed. So moving on, is the formula. This is you guys can take notes of this formula. We're going to use it so much in arithmetic sequencing because this formula helps us to find the next term. So n is the position of whatever term we are being asked. A1 is the first term in that sequence, and then n is the number of the position of that term that we are being asked minus 1 over d. Okay, let's just hopefully the next one is an example so that I can just, okay, this it's just an explanation of the terms that are involved in the formula. An is the term that you are looking for, a1 is the first term, n is the position of the term is in. Whatever position that term that you are being asked to look for is in, you minus 1 from its position, and then you multiply that with a common difference, and you will be able to find your next term. And moving on, here's an example finally. It says find the 14th term of an arithmetic sequence. You are looking for the 14th term. First of all, here, before you even start looking for the 14th term, you have to determine whether this sequence is an arithmetic series or not. So you start with your 7 minus 4, that is 3, 10 minus 7, that is 3, 13 minus 10, that is 3. So the common difference is equal to 3, and it's constant, meaning that this series is an arithmetic. So you can go ahead and use the formula to find your 14th term. An, which is the a 14th term, a 14th term is equal to a1, which is the first term in the sequence 4, and then n, which is the position of the term you are looking for, which is the 14th, 14 minus 1 over the common difference that we found by subtracting 7 minus 4, 10 minus 7, and 13 minus 7, which the common difference was 3. So, and then you do 14 minus 1, and then 4 plus 13 multiplied by 3, and then you get your 14th term to be 49. Okay, moving on. So the 14th term in the sequence is the number 49. 49, yeah, 43, I mean, sorry. Okay, this you can copy it down and try it, and then you can write the answers in the chat. 1, 7, 13, and 19. Okay, moving on is finding the nth terms of an arithmetic. We are still on finding the arithmetic term, which we do by first finding the common difference. The common difference there is 4, and then you write the rule to find the 16th term using the formula an is equal to 1 plus n minus 1d, and then you substitute, and then you get your nth term. Okay, to find your nth term, because this example continue, find the indicated term of an arithmetic sequences. The term, the 20th term, and common difference, write down the nth term. Okay, you just use the formula substitute and you will be able to get whatever term you are being asked. There's an example to indicate the term. You first find the common difference among the pattern. You know that the common difference is -6, and that series is mathematics, so you can go ahead and use the formula for an arithmetic series. And very easy. You just need to practice and you'll be fine. So this is find the indicated term of an arithmetic, the 12th term. They asked me to find the 12th term, given that the first term is that, and then sorry about that. Okay, sorry again. Moving on. Moving on, it's a find the indicated term of an arithmetic. It's the same thing. You just use the formula and plug in your values. Okay, the last example is a very practical. Okay, let me quickly just attend to this. I'm so sorry about that. Okay, moving on, it's an applicable example. It is a bag of cat food weighs 18 pounds. Each day the cats are fed 0.5 pounds of the food. How much does the bag of cat food weigh on day 30? Now this is an arithmetic series being put in a practical example, which should be very easy for you to understand, for you guys to understand. So the first step we are going to do is determine whether the situation appears to be arithmetic. So the sequence for the situation is arithmetic because the cat decreases by 0.5 pounds each day. You determined that was determined based on this statement. It says each day, meaning that it's constant, something that keeps happening each and every day. So that means it's an arithmetic because of that. The next step, you have to find your common difference, find your first term, and find your nth term. So since the weight of the bag decreases by 0.5 pounds, so the D is equal to negative 0.5. It's negative because the cats are feeding on the food every day, so the food is decreasing. It's being taken away, so it's a negative 0.5. So A1 is the first term. The first term says the bag before the cats feed from it, it initially weighs 18 pounds. So the nth term, the first term is 18. So step 3, that will be your homework. So you guys can complete these questions and find the what we have discussed so far. So far we've discussed what an arithmetic series is, how to determine it, how to identify the nth term, how to find the common difference, and how to apply it in practical daily activity, like the example that we have, and which is you guys' homework. You guys can just go ahead and copy that, and I will need it in the next lesson, please. So thank you so much, guys, for being here. If you guys have any questions and anything that you want me to clarify on, or anything in general, because we have came to at the end of today's lesson. Any questions, comments, or anything that you guys would like to add?
No comment, ma'am. Everything was good. We understand.
Thank you so much, guys. Don't forget your homework in the next lesson, and thank you so much for being here. So I'm going to stop recording and end the lesson, so you guys can exit on your own. Thank you.